am Shalaka Deshpande. In the previous class, we studied about the parallel ports, okay, and we also discussed what are the serial ports, parallel ports, input ports, output ports, okay. So in this class, we are going to study about the types of communication. I mean to say, whenever there is a communication, bits are transmitted from sender to receiver, okay, and the way in which bits are transmitted determines which type of input you are dealing with. Okay, so there are two types of inputs. Okay, let's get started. Synchronous and asynchronous serial input. Okay, and execution speed. Our today's topic is synchronous and asynchronous serial input and execution speed. So first we will see what is a synchronous input. See, synchronous input means whenever we are transmitting the bits. Now one byte consists of 8 bits, means there are total 8 bits of 1 0 1 and so on pattern in a single byte. So single byte consists of 8 bits. Okay, so each bit in a byte is separated by a constant time interval, or we can say it is a fixed time interval. So that is a synchronization, means every byte in the bit stream is separated by fixed time interval, and when it is like that, we say that the communication is a synchronous communication. Okay, so it is a very important point. See, in the synchronous communication, there is a bit stream, and bit stream consists of various bytes, and one byte consists of 8 bits. Bits are separated by constant time interval and bytes are separated by constant time interval. Both the time intervals are constant. For example, I am transmitting the byte 1 and byte 2 and then the byte 3. The distance between byte 1 and byte 2 is 4 seconds, and distance between byte 2 and byte 3 is also 4 seconds. So it is a fixed time interval, so we can say it is a synchronous input. Okay, I hope it is clear. Now next, you can see these are the clock pulses. I have drawn the diagram of a clock pulses, sender, receiver, parallel in serial out register and serial in parallel out register. Now what is the role of registers? Now see, in the synchronous communication, what exactly is happening? Whenever a sender sends a bit stream to receiver, along with the bit stream, the sender is also sending the clock pulses. Okay, so clock pulses and bit stream, they are sent together, and clock pulse and bit stream are synchronous to each other. What do you mean by that? See, at every instance of a clock pulse, the bit stream is sent. Okay, instant means what? Instant of a clock pulse can be anything. For example, it is logic 1, midpoint of the logic 1, midpoint of the logic 0. Okay, or it can be a low to high, high clock pulse, or high to low, low clock pulse. Means at the midpoint of the logic 1, we are transmitting a bit. Okay, or at the midpoint of the logic 0. I have given the example of logic high midpoint, but it can be anything. We can also transmit the pulse at the midpoint of a logic 0 level. Okay, so the bit stream is transmitted along with the clock pulses in the synchronous communication. Synchronous serial input. We say the input is a synchronous input, means clock pulse is transmitted along with the bits. Okay, now, okay, now see here, there is a diagram of a sender and there is a diagram of a receiver. And there are registers. Now you can see that there is a parallel in serial out register at sender and serial in parallel out register at a receiver. What do you mean by that? See, whenever the sender is transmitting a bit stream to receiver, or whenever a bit stream is received by receiver, where will it store the byte? Bit stream consists of various bytes. We need to store those bytes. And where are we going to store the bytes? Registers. And how are we going to manage to send or receive the bytes? Through parallel in serial out and serial in parallel out registers. What is exactly happening? There is a parallel input at a sender's end. So input 1 0 1 0 or any combination is sent along the parallel lines. Then it is converted into serial output, and that serial output is received by receiver, and that serial output is again converted into your serial input which receiver is receiving is converted into a parallel output. Okay, so in this way the transmission takes place between sender and receiver with the help of registers. Now how do we measure how many bits are transmitted per second? How do we measure rate of transmission? See, rate of transmission is measured by 1 upon t bps. Okay, 1 upon t bits per second, where t is a time period in which bits are transmitted. Okay, how many bits are transmitted in the 1 second? 1 upon that time period is nothing but the transmission rate of that bit stream. Okay, or transmission rate of that communication. Now we will move towards asynchronous serial input. Now what do you mean by asynchronous serial input? Synchronous we have understood, right? I hope you have understood that. So asynchronous. What do you mean by asynchronous serial input? See, as I told you, whenever we want to communicate, there are bytes. Okay, bytes is sent from sender to receiver. Okay, bytes we are sending, and each byte is having a bits, consist of bits. Now in asynchronous serial input, the bits are at a constant time interval, but the distance between the successive bytes is different. Variable time interval. Asynchronous variable time interval. What do you mean by variable time interval? Suppose I have to transmit the 3 bytes. So the distance between first and second byte is 4 seconds, and distance between second and the third byte is 6 seconds, right? So first 4 seconds and then 6 seconds. So time interval is changed now. Okay, so changed time interval, whenever there is a change in the time interval, means time interval between the bytes is not fixed, we say that the serial input is a asynchronous serial input. Okay, fine. And in the asynchronous serial input, we are not sending clock pulse. This is cross. We are not sending clock pulse in the asynchronous serial input. That's why it is called as asynchronous. Okay, fine. And how do we measure it? We measure it by 1 upon t baud per second. What do you mean by baud? Baud is a German word for raindrops. Like bytes come from sender to receiver like a rain which comes at an irregular time interval. So bytes are received by receiver at irregular time intervals. Okay, fine. So that is a asynchronous communication. Fine. I hope you have understood what is asynchronous communication. Okay, it is very simple. Okay, once you know what is synchronous and know how many relationship between byte and bits, you can easily understand what is a synchronous and asynchronous serial input. Okay, now next part is the execution speed. Okay, now see execution speed. Now whenever the processor fetches the instruction, I hope you have general idea about the microprocessor and microcontroller architecture. We are going to cover it in the 4th chapter, don't worry. Okay, so for now you just remember that whenever a microprocessor or microcontroller fetches an instruction, we say this instruction require 4 machine cycle, that instruction require 1 machine cycle, this instruction requires 6 machine cycles. Okay, we say like that. So what is a machine cycle? What is the execution speed of a processor? See, the execution speed of a processor depends on the frequency of a clock pulses. It depends on the frequency of a clock pulses. If the frequency of a clock pulses is high, okay, number of cycles per unit time is high, then we say it is having a high clock frequency. And if the clock frequency is high, speed of the processor is also high. Okay, and if the clock frequency is low, speed of the processor is also low. So execution speed, in how much time it is executing the program, that depends on your clock frequency. Like the heart provides a blood to all the part of the body, the clock is provided by oscillator unit to processor so that it can control all the operations of the processor. Okay, so oscillator unit is compared with the heart in the human body because it is a very important unit in the processor or a controller. So in this way the oscillator unit we are going to cover it in detail, but for now you just remember that one machine cycle consists of the 6 T states. There are total 6 T states. Okay, and every t state is divided into P1 and P2. Why we are dividing it into P1 and P2? Period is a P1 is a period 1, P2 is a period 2, and S1 consists of the two clock pulses. I have drawn the diagram. See, there are two clock pulses. So T state S1 consists of the two clock pulses which is having the period P1 and P2 respectively. So okay. So in one machine cycle there are total 12 clock pulses. Okay. So machine cycle, it consists of the T states, 6 T states, okay, and 1 T states consists of the 2 clock periods. Okay. I hope you have understood the concept of machine cycle. Okay, and if you have any doubts, you can tell me in the comment section below and I'll solve your doubts, no issues. And please like, share and subscribe my channel. Thank you very much.